Hi, this is Irv Shapiro with the MakeWithTech YouTube channel, and welcome to the MakeWithTech lab. All of it today, and you can see so much of this lab, including the exhaust fan on the wall and the mess in the corner and my microphone, and I think one of the lights, one of the backlights is in view, all because I'm doing a review of a very tall printer. Now, when I did a review a couple weeks ago of the Ender 7, I thought that was the largest printer I was going to review, and it still might be by far the heaviest. This is much lighter than the Ender 7. But this is very, very tall in particular because I don't even think it's in the shot necessarily. The filament reel is on top. So for most of the video, we're going to be zoomed in because this is really the part of the printer that you need to look at. But for right now, I wanted to show you the whole thing. Now, what has me excited about the Flsun Speed Racer? Well, it's advertised as being very, very fast, and that really isn't the exciting part for me, because as I said, I looked at an Ender 7, another fast printer. I'm sure they're both similar or different. We'll figure that out today. But the only Delta printer I'd ever looked at before was this little Monoprice Mini Delta. I actually looked at the V1 and the V2, and they're okay printers, but in reality, for most of the things I want to print, they just don't fit. Even this pawn doesn't fit. And so, unless you have a specialized application, the print area of these printers is not large enough. That said, I was fascinated with this mechanism that you use on a Delta printer, and we'll be showing you some videos of this device working, and it's mesmerizing to watch. So if you want to learn about the Flsun Speed Racer so that you can evaluate whether a Delta is in your future, stay tuned and we'll learn something together. Overall, for those of you that are new to the channel, I'll just introduce myself. MakeWithTech is a channel that teaches people how to use desktop technologies. This is a pretty big desktop technology. Many of them are smaller in order to make, create, and innovate. So if you're interested in learning how to become what some people call makers today, learning the things that your kids or grandchildren learn in STEM class, this is the right place to be. So subscribe, give me a thumbs up if you like this video, share this video link with everyone you know, and click on the bell if you want to be notified about upcoming videos. This is a Delta style printer. That means instead of having a set of belts that move a print head side to side and back and forth, potentially up and down, or move the print bed up and down, it uses 3-stepper motors and suspends the print head on an arm, and by adjusting those 3-stepper motors that pull on belts in each of these extrusions, it's able to position this print head. It is absolutely fascinating to watch. The math required to do this is more complex, and so generally, Delta-style printers often have a bit more power in their processing boards. Now that most 3D printers are moving to 32 bits, any of the 32-bit control boards could control a Delta-style printer. Now, when looking at the size of a Delta-style printer, you only get two numbers. 260, which is the print area, because it's round. So it's 260 millimeters by 330 millimeters. Now, how does that compare? Well, let me take the print surface from a Ender 3 or 5 to give you an idea. And you'll see that it sort of fits inside of it. This is 220, not 260. But you're missing the corners. So corner to corner, this is larger. 330 is excellent. Now, why is this printer so tall? 330 would be about here. Well, because the arms that control this, even when this print mechanism is all the way at the top, still take quite a bit of distance. So it's really the distance from here to here, which is the overall maximum print height. Now, what are some of the other features of this printer? Well, one feature that's interesting is the print head, the print mechanism, is very, very light. It's one of the lightest I've ever used, but it's designed to handle very high volumes of filament extrusion, because when you're printing fast, you need to be able to push out more filament. So it's basically a clone of a V6 Volcano hot end, which is a well-known design. This hot end has 3 fans on it. 2 that are directed towards the print, and 1 that's directed towards the heat break to cool off the filament. Likewise, the extruder, which you really probably can't see well here, but I'll show you close-ups as we go of all of these components. The extruder is a clone of the E3D Titan extruder. It worked great. On top of the extruder is a filament out sensor, and I tested that. It works. We'll talk about that a bit more in a minute. The print surface is a bit interesting. The print surface is textured glass. Some people love these new textured glass surfaces. Some hate them. You see them on a range of printers, so there must be some manufacturer making this textured glass material or making the laminate. I don't know if it's actually a laminate on top, how it's bonded. But in this particular case, I'll tell you, it worked very, very well. I did clean it with just plain water, rubbed it down well between each print, and it stuck very, very well. In fact, it stuck too well. Now, on other printers with this type of surface, when it sticks too well, I take the print bed off, I put the whole thing in the freezer for 5 minutes, it gets nice and cold, the print comes right off. I couldn't do that here because this print surface is bolted in with 3 brackets, 6 bolts. Now, it does come off. You can replace it. It's not bonded to the heating element underneath, but it's not something you're going to want to do every day. So if you're in a production environment and you want to be able to take the print surface off with the prints to let them cool and immediately start printing again, this probably is not the printer for you. But I found a great solution. Go to any big box retailer and buy one of these. It's called a fan. So I took and I set this in front of the printer. About 5 minutes, really no longer than the time it takes me to walk to the freezer, put my print in it, walk back, walk to the freezer, check again. I put it on high. 5 minutes, the print surface was cool. Prints popped right off. Now, this print surface is very sensitive to temperature variations. There's a very specific temperature that you need to be at or below for prints to come off. If this print surface is over about 23 degrees Celsius, your prints won't come off. If it gets below that, they will come off. Now at about 30, 35 degrees Celsius, this will feel cool to the touch. Your prints still won't come off. So just keep that fan on there, let it cool off, and the prints will come right off. This printer is quiet. Let me turn it on for a minute just so you can hear the fans. And that's really the only noise you'll hear other than the extruder, which seems to be a bit noisy when it's doing retractions back and forth. So overall, this printer is very, very quiet. That's because it does have TMC 2209 stepper drivers. Those are the chips on the control board that control the stepper motors that are mounted actually down here on this printer. Assembly of this printer was very straightforward. Basically, you bolt these 3 columns on, you bolt the top on. You do have to put the arms in place and slide in the extruder. That's easy to do. The arms are also very light. They're made of carbon fiber. Everything here is quite light. Now, the front controller panel is unique. It's on a little stretchy cord. And if I turn it on here, you'll see it comes on. It attaches to the printer on a magnet, and it is very simple. There are only 4 options on here: print, tools, set, and info. And set is a disappointment. It's not really filled out with all of the parameters I might like to change in a Marlin 2 based printer. And this is running real Marlin 2.0. Matter of fact, it tells you here it's running Marlin 2.0.8, and I've attached it to a USB terminal and verified that. Tools does a good job of giving you the information you need to level this printer to load and unload filament. When leveling this printer, you take and attach this little probe that's held on with a magnet to the bottom of the print head. And you plug it into the cable up here. You go to the front panel, you follow the instructions. It works great. Then you take it off, and I don't know if this drawer was made for this purpose or not, but I put it right here in the drawer because then I'm sure I won't lose it. Now you might say ABL systems where you have to clip it on and clip it off, they're not very practical because you really want to probe before each print. Well, I do on a printer where the print bed is moving back and forth or up or down. This print bed never moves. As I mentioned, it's bolted in. So once you level this, it's probably going to stay level a really long time. I did it 1 time. Now, loading filament is very interesting because when you tell it to load, unlike a lot of printers that extrude, I don't know, 10 millimeters, 20 millimeters of filament, 5 millimeters of filament, this just keeps extruding filament. And the loading process is extremely good. You put the filament in the top of the extruder, you click load, you set the temperature, comes up to temperature, and the extruder will push it all the way through this Bowden tube, which is sort of a medium length Bowden tube, out the nozzle, and just wait for it to finish. Unload works the same way. It first does a bit of extrusion, then it pulls it back and unloads it. So those options work really well, which will make it much easier for people new to 3D printing to use this printer because it's easy to load filament, it's easy to level the print bed. This printer is included in current builds of Cura. So I'm on a Mac. I didn't use the version of Cura, which is a bit older. It's 4.4. I think I'm using 4.12. That was on their SD card because there is a version on the SD card, along with some very good videos on assembling this. Those videos are so good, there's no reason for me to show you how to take this out of the box and assemble it, since the videos are on the Flsun website and on the SD card. In terms of loading prints into this printer, it has a USB connector. I'll show you a picture of it because it's over on this side you can't see. It's up on the top, which is really nice. And what's also nice is the SD card goes in facing up, not facing down. So that's just a nice touch. It also has 2 USB connectors. One that is a printer style USB connector, that's the one used to access the printer, and one that looks like it's for USB drives. But you can't use the USB drive style connector and the SD connector at the same time. You actually have to change the firmware. I didn't do that, so I didn't try plugging a USB key or what they call a U-disc, which is technically a little bit different but similar, into this device. Instead, I just used the SD card and I tested it with a USB cable, and both work. Now, something unusual about this printer is, besides all the standard goodies you get it with every printer, a diagonal cutter, in this case they give you a small reel of filament, all the screws you need, a screwdriver, some Allen keys. They also give you 3 things you don't always see. They give you a hot end block, heat break, and nozzle pre-assembled. So if there's any problem here, if that jams, you can slide this one in while you work on the other one. They give you a spare heating element and a spare thermistor, something I haven't seen before. They also give you a spare Bowden tube. So you should pretty much have everything you need to maintain this for quite a bit of time, except that if belts were to break. Now, what does this printer cost? Well, it was originally priced at $650 on the Flsun website. More recently, it's on sale for $600, actually $599 on the Flsun website. On Amazon, you can find this printer for $500. And at some other sites, you can find it for about $450. Assuming this printer does what it's advertised to do, that is print very, very fast, has a large print area, it has a filament out detector, it has power fail recovery, it has high quality hot ends and extruders, it runs real Marlin 2.0 and the source code is right on the website for the company. If that's all true and it all works, $500 is a bargain for this printer. Okay, now before we look at print samples, I want to talk about Cura for a minute. When you install this printer in Cura, and I'll show you some screen captures of this, there are two profiles listed. One called Fine, the other called Normal. Normal is a 0.2 millimeter profile, pretty typical, except that the base speed is set at 150 millimeters per second. That's fast. Now, not as fast as the Ender 7, which is set at 250, but it's set at 150. And we'll see how that ends up working out. Fine is a 0.12 millimeter profile with a base speed of 80 millimeters per second. Still relatively fast. Now, I did some changes because for my benchmarking, I wanted things a bit different in how they were structured. So I've used the default profile. I've taken the default profile, the 0.20 millimeter profile, and basically I've set the speeds to the same as Fine. So I set the default speed to 85 and then made all the adjustments. And you'll see I also ended up creating a 50 millimeter per second profile. Because I wanted to see how fast was this printer, printing at their Fine recommendation, how good was it? And then printing at the speed you'd print on a typical printer when you want good quality, let's say a Ender 3 class printer and Ender 5, how would it do at 50 millimeters per second? And we're going to take a look at all of those. But first, let's look at a few more details on the 150 millimeter per second profile. You'll see here that on this profile, the 150 millimeters per second is the top line. And this is running a real version of Cura, so that impacts a lot of things. But a number of the other parameters are a bit different. So outer walls at 75, inner walls are still at 150 because you don't really see those. So if they don't look perfect, you don't see them. Top and bottom are at 70. That's pretty good speed for top and bottom layers. Support is at 80. Travel is at 150. I've seen printers push that higher. The initial layer is at 25, which is really relatively slow, but it seems to work well. And interestingly enough, acceleration and jerk are not set in the slicer. They're using the defaults in the firmware. Both those features are off. So typical acceleration, which is the rate at which you can come up to the full speed you're going to print a particular layer, is about 500 millimeters per second squared. And that's typical for most printers, including the faster printers I've benchmarked. So I hooked a G-code terminal, and I'll show you a link for this, but there's a free G-code terminal that I built for my viewers that you can use right from a browser. So if you have Chrome or Edge on your printer, you can go to this website and use it to connect to a printer and fine tune it. So I hooked my G-code terminal to this printer to look at what acceleration was set at. And here's what I found. I found that acceleration was set to 6,000 millimeters per second on this printer. That's fast. And that's going to have as much impact as the top line speed on the speed of the printer. So it's going to be very interesting to see how well this printer does in actual tests. First thing I printed was one of the models on the SD card. It's a really fun model, and it's a beautiful, beautiful print. Now you'd expect this. I'll show you a close-up of this. But because the bolt head and the nut are textured and you have threads here, you can't really judge print quality other than the bottom. It prints in this orientation, and that's nice because it's on this textured print surface. It works great. But then I printed something a little bit more practical. I printed a large vase. Now, this vase print is not printed in vase mode. This is printed in traditional print mode with the top layer set to 0, the infill set to 0, and 3 lines in the walls. So you end up with a really strong watertight vase. And this is a good quality print. Now, this is a print, the filament's different, so you can't necessarily compare quality directly. This print came from an Ender 7. Now, using the default settings on the Ender 7, this took 4 hours and 25 minutes to print, which is pretty fast. It'd be about 7 hours on an Ender 3. Believe it or not, this printed in 2 hours and 40 minutes. I was blown away with how fast that was. Now, when printing a vase like this, there are not a lot of long runs. So even if a printer can go 250 millimeters per second, it needs to be able to get up to speed, and that will depend on the acceleration setting. So because this printer's acceleration is so fast, is such a high number, it prints items even with short segments very, very fast. Quality-wise, they're similar. They're a little different if you look at them, but once again, different filaments, so I couldn't really judge that well. Next, I printed one of the Kickstarter quality tests. And it came out poor. I would rate it C+, B-. On many of the overhangs, there's actually filament hanging down, touching from one layer to the other. The towers at the top are a mess. Now, a lot of printers have trouble with those towers, but I'm going to show you a close-up here. And in this close-up, I adjusted the contrast and the lighting to make it really evident what the print looks like. And you'll see there's terrible ghosting on this print. So I wasn't impressed with the quality. Now, this printed in 2 hours and 13 minutes. Normally, these take about 4 hours to print. So it's fast, but the quality wasn't excellent. Next, I printed one of my favorite prints, and that is to print a 2x 3D Benji. And I do that with big printers because I want to test big things on big printers. And this print is pretty good. It'd be very acceptable if this is a bathtub toy, which these work very well as because they're hollow in here, so they actually float. This would be great. And this printed in 2 hours and 52 minutes. Same print on a Ender 7, and that's this one here, took 4 hours. Once again, why is this so much faster? Because of acceleration. But the quality on this print is much better. So this Ender 7 print is much better, and you see in the close-up here on the screen, see those lines? That's a phenomena I saw on a number of the prints at the highest speeds. You'd get this sort of banding effect. It's almost like a minor layer shift on various prints. So we have to watch that as we go through these samples. Now, I assumed this printer could do better quality than that. So the next thing I wanted to do is I wanted to learn more about Delta style printers, and in particular, how you tune them up. So I'm going to take my little mini Delta here, which is not the same. This is once again from Monoprice, but just to show you the parts because it's easy to demonstrate. Inside here, you have a belt on each of these pillars. And that belt is used to manipulate, to pull the print head up and down. The tightness of those belts matters. And what I found, both for the Delta and now for this printer, is that people often use musical tuning devices to tune their printers. Because when you take one of these belts, I'm going to show you a movie of this right now, a video of this right now, and you take and you pluck the belt, and I don't know if you can hear it here. Watch this close-up here. In this close-up, you can see and you can probably hear that you can hear that belt. On this printer, there's a very easy mechanism for adjusting these belts. You loosen 2 bolts that lock it in place, and then you turn a knob. On the Facebook website for Flsun for this printer, Paul Hankin has a very nice write-up of using an app called Pano Tuner. So I took that app, I'll show you a picture here on the screen, and I put it up next to the printer, and I plucked the various individual belts. And Paul recommends you set each belt to about 60 hertz. Well, this one was at 40, this one was, I think, at 90, this was over 100. They were all over the place. So I knew the tension was different. So I adjusted all of the belts by loosening the 2 bolts, adjusting the screw, using the tuner, plucking the belts until I got the same sound from each of them. Now, I guess if you're really good, you could look at deflection under a certain force. There are many ways you could do this. On the Flsun website and on the SD card, there's a video of how they recommend doing it. But this piano tuner approach, and you could use any instrument tuner. You could use a guitar tuner. You just want to tune them so they're all at 60 hertz. So I took and I changed them all so they were at 60 hertz. So I know the tension on these 3 belts are all pretty darn close. Then I took and I reprinted this Kickstarter model using the slower speeds, the 80 millisecond per second speeds that I took from the fine profile, but put back into the 0.20 layer height profile. And with the tune belts, it's a much better print. You can see here on the screen here that the lines on the front are nice and clean. There's minimal, I can't see any ghosting at all. I still see a little bit of these lines here, and you can see that on the print I'll put back on the screen. And the towers are good. I'd call the towers average to better than average. A lot of printers can't complete these at all. So this was a good print. So we were making progress at saying that at very high speeds, you're going to get a little less quality, but boy, does it print fast. At moderate speeds, you're going to get good quality, maybe B plus quality. We're not at A quality yet, so I need to do some more testing. Next, I printed 3 pawns that I had modeled in another video in FreeCAD to demonstrate FreeCAD, just to show you the impact of these various speeds. The quality is similar. You can see if you look very closely, I'll show you the close-up here. If you look very closely on the one printed at the highest speed, you can see the seam a little more. Not exactly sure why. So one was printed on an Ender 3. That took 3 hours and 41 minutes. The next one was printed at 80 millimeters per second. That took 2 hours and 18 minutes. And then the last one was printed at 150 millimeters per second. That completed in 1 hour and 12 minutes. So Ender 3 was 3 hours and 41 minutes. Highest speed here was 1 hour and 21 minutes. That's remarkable. And for this print, I don't think it would make a difference. Now I looked at printing 3 calibration cats. Now, calibration cats I'll show you on this one. This one was printed on the Speed Racer. I'll explain what the parameters were in a minute. But they're designed so that you can take a caliper and you can measure the dimensions in order to judge whether extrusion is working well. So this is supposed to be 20 millimeters. It's 20.2. That's very good. And in this dimension, it's 20.15. So it's over extruding very, very tiny amount. Let's look at a picture of these 3. On the left is a calibration cat that was printed on an Ender 5. In the middle is a calibration cat printed on the Speed Racer at full speed standard default settings. And look, he looks sort of like he's melting. So clearly the quality is not there for fine features when printing at very high speeds. On the right is a calibration cat that was printed at 50 millimeters per second. So basically the same speed as the default speeds on an Ender 3, Ender 5. Sometimes Ender 5 is a little bit faster, but generally the same range. And I wanted to see if whether slowing this printer way down, I could get really good prints. And this is a really good print. There's a little tiny bit of banding opposite where the whiskers are. And I think that's just a phenomena of a type of shadowing that you get on this type of Delta printer. It's because I've seen that across the board. Now, finally, I printed one more print, a toy, which is really a lot of fun to play with. You have to find the right axes for each of these. And this is a toy that you can rotate around, and it's sort of a fidget toy. And I wanted to determine whether the clearances printing at the slower speed would be good. So this is printed at the slower speed, and this printed as well as it's printed on any printer. Now, one problem I had with some of the recent printers from Creality is that they have a bug in the firmware where, because of power fail recovery, and this printer has power fail recovery, they don't print properly in Vase mode. Well, this beautiful print was printed in Vase mode on this printer, and there are two defects that you'll see over here. You'll be able to see it in the close-up a little better. The first one was caused by that jam on the filament reel. So I had a jam on the filament reel, it stopped feeding properly. I hit pause. Now I was a bit surprised that in the pause menu, there wasn't a change filament option. So I manually changed the filament, but then I wanted to see, does the filament out sensor work correctly? So I took a diagonal cutter and I cut the filament, and it worked perfectly. I did get a little defect. In that case, it gave me an option to replace the filament. Okay, let me wrap this all up. So what do I think? First off, I think this is a bargain. I think the features, the speed, the performance, the quality you get on this printer for about $500 is a great buy. In terms of speed, this is the fastest printer I've ever tested. And it did that well, but at the highest speeds, and this is the best example to look at, but even looking at this example here, at the highest speeds, your quality is going to suffer. And it suffers more at high speed than other high-speed printers I've tested. On the other hand, the highest speed on this printer is much faster than any other printer I've tested. If you slow this printer all the way down, you are able to produce beautiful, beautiful prints. And even at the intermediate speed, which is still faster than a typical 3D printer. So this took, at the intermediate speed, this took 2 hours and 18 minutes on the Ender 3. This is 3 hours and 41 minutes. Still much faster. You do get decent quality. So I can recommend this printer for people that are looking for large print volume, very high speed, good solid quality, but you'll need to do some work if you want outstanding quality. Thank you so much for watching today. I hope you learned something. I found this fascinating to really dig into Delta printers. The whole thing about tuning the belts was a lot of fun. So if you enjoyed this, if this worked for you, please subscribe to the channel, click the bell to hear about new videos, share these videos with everyone you know, and go to forum.makewithtech.com to talk about this or leave a comment below. Thanks so much. Let's continue to learn things together.